Okay, in this video we're going to be looking at question 2 from the WJEC additional maths paper from June 2014. We can see part A is just a simple factorizing of a quadratic. So when we have a quadratic that we need factorizing that involves an x squared, an x and a number, a constant, then I use this 2 by 2 grid here to help me. So I always start off with the x squared term being in the top left box, so 15 x squared, and the constant in the bottom right box. And then the two boxes that are left over that I've highlighted, they will make up our x term. So we're going to split them over two boxes. So we need to figure out how many are in each of these. So the way I do it is I multiply these two values together, 15 times negative 8. So that is 15 times 8 is 120. So I'm going to deal with 120 for the time being when I work out what multiplies to give us 120. So I got 1 and 120. There's going to be a fair few of these, so I'm going to make it quite small. 2 lots of 60. 3 lots of 40. 4 lots of 30. 5 lots of 24. 6 lots of 20, 12 times. Okay, now because these two numbers, excuse me, now because these two numbers need to multiply to give a negative, that means one of the values in the pair has to be positive, the other one has to be negative, and because when they add together they give an overall negative value, and that means the larger number has to be the negative one. So I'll put the negative signs on all the larger numbers. And then we can see which pair will add up to give negative 14. Well, it's going to be this one here, 6 and negative 20. So that's going to be the number of x's. So I'm going to put 6x in one box and negative 20x in the other. Doesn't matter which one's which. So plus 6x and minus 20x. And then I'm going to start factorizing by the rows. So I take this row here, this top row, and see what is in common in these two terms. So 15x squared and 6x. Well, 15 and 6 both share a highest common highest common factor of 3. And x squared and x both share a common factor of x. So I can write 3x by there. Now it's a case of figuring out what multiplies to give us this 15x. So you have 3x times something gives me 15x. Well, that's going to be 5x. And 3x times something will give me 6x, which is going to be plus 2. Similarly, this value multiplied by 5x is going to give me negative 20x. So that's negative 4. And as a final check, these two should multiply to give us negative 8, which they do. So I have my two factors. I just need to write them down in factored form. So therefore, 15x squared minus 14x minus 8 is exactly the same as writing 5x plus 2, 3x minus 4. Okay, the next part says, hence solve the equation. Now, we couldn't find the value before because we didn't have an equation. Now we have, let's just double check, 15x squared minus 14x minus 8. It is the same expression, equal to 0. Now we can only solve quadratics when they're equal to 0. So now we can say, okay, that quadratic is equal to 0. And if that quadratic is the same as 5x plus 2, 3x minus 4, then that also has to be equal to 0. So now we have a product that gives us the answer 0. So in order to multiply to give us 0, then either the 5x plus 2, so the first term, is 0. So then you'll have 0 times something, which will be 0. Or the second bracket, the 3x minus 4, has to have the value of 0. In which case you'll have something times 0, which will also give us 0. Now we have two linear equations to solve. On the first one, I'm going to subtract 2 first. So I get 5x equals negative 2, and then divide by 5. So x is negative 2 fifths. And on the second one, I'm going to add 4 first, so I get 3x equals 4, and then I'm going to divide both sides by 3, so I get 4 over 3, or 4/3. And those are our solutions. Part B, use the method of completing the square to find the least value of this quadratic, x squared plus 10x plus 3. So if you want an explanation of the completing the square, please go to the videos when I run through the additional math course. But all we have to do with this x squared plus 10x plus 3 is open some brackets, halve the coefficient of x, so I get x plus 5, so that's half of the coefficient of x goes in there, all squared. Then I always subtract the square of this number, so minus 25, and then I put on the value that I need, so plus 3. Okay, the reason that works is that if I expand this bracket, I get x squared plus 10x plus 25, which x squared plus 10x is what I wanted, which is great, but I've got this plus 25. So the first thing I do is I get rid of that plus 25 by taking it away, and then I put the plus 3 on that I need. Then I can tidy this up, so that means this is equal to x plus 5 all squared minus 22. So both of those constants affect the graph in particular ways. So this plus 5 actually shifts the graph 5 units left. And the minus 22 shifts the graph 22 units down. Okay, here's my axes, and this is the standard y equals x squared graph. So that has the minimum point here of 0 because it drops down lower and lower and lower until it gets to its lowest point, which is at 0, and then starts going up again. So I'm going to take that graph and I'm going to shift it 5 to the left, 5 to the left. There's no scale, so it doesn't matter. So all I know is that that's gone 5 to the left, and that'll make that negative 5. And then it's going to go 22 down, so I'm going to move it downwards, so say about there. So that means that is going to be about 22 down, so negative 22. Okay, so what that means when it talks about the least value is the lowest value that this graph can take. So at the moment, it's getting smaller and slower, less and lesser and lesser and lesser, lower and lower, smaller and smaller and smaller, until it hits this point. The graph doesn't get any lower, any less than negative 22. Okay, then it starts increasing in value again. So I can say that the least value is negative 22, and that happens when x is negative 5.